So there's some stuff written on the screen. This is because I started this video and punted on what I was writing. I didn't feel like deleting it, so I'll just start over. I was kind of fumbling with my words. Hopefully I can do this on my second go. So in section 2.3, I need to lecture on a little bit of theory before I jump into solving the problems. And the section must be titled something to do with inequalities as opposed to equations or equalities. I'm trying to spell on the video. These are inequality symbols. The symbols greater than or equal to, less than or equal to are the symbols that we're going to see in this section. And what we're going to need to be able to do to get started is if I give you an inequality, a problem that has a variable with one of these symbols, we need to represent the inequality on a number line. There's kind of a couple different ways to do this. Both of them are essentially the same, and I'll show you both. So I'm going to make a number line that has 0 and positive integers, 0 in the middle, positive integers marching off to the right, negative integers marching off to the left. Eventually I stop writing integers. I can't write all the integers that are possible because number lines extend forever to the right, and the far right edge of a number line has positive infinity. Lines extend forever to the left, and the far left edge of a number line has a negative infinity. So I'm going to represent x is greater than or equal to 3 on a number line. Immediately I know I need to indicate the number 3, and I'm going to find 3 on a number line, and I'm going to put a solid circle, meaning this inequality is true if you plug 3 in for x. 3 is equal to 3, so it's considered greater than or equal to 3. And now I'm going to shade the direction of the number line where the numbers that I shade over or draw a line over are all bigger than 3. And clearly, numbers to the right of 3 are bigger than 3. This is a pictorial representation of x is greater than or equal to 3. It has the number x equal to 3 and an arrow over all the numbers that are bigger than 3. And any number that is not equal to 3 or that is less than 3 isn't pictured with a line. So I would say this is a representation of this inequality on a number line. The other way that we might see this represented, I'll make a less complete number line, is instead of writing a closed circle on the 3, you might see a square bracket on the 3. This is kind of a nice notation. I almost prefer it to the closed circle because it ties better into what we're going to do next. That being said, even though I might prefer this, the only number line drawer I could find on the internet does open and close circles. So my keys will have these, so I need to be consistent with myself. So I represented this inequality on a number line, and the other thing we're going to need to be able to do is we need to be able to represent using intervals or interval notation. I need to describe all the numbers that satisfy that they're greater than or equal to 3 using an interval notation. And that's super easy to do. I'm essentially just going to look at the numbers that my arrow's covering up. My dot starts at 3, my arrow goes forever. Even though I stopped this line, it doesn't really stop. The little arrow I put on it implies that it keeps going to the end of the number line. I just stopped drawing and the arrow signified that it went on forever. This inequality, x greater than or equal to 3, represented using an interval, would be the interval starting at 3, including 3, going to infinity. I always put a round bracket on infinity because there is no infinity. Round brackets mean you can't equal the number. Square brackets mean you're allowed to equal the number. Here, I'm allowed to equal 3 because the inequality has an or equal to symbol. But there's just no way to equal infinity because infinity is just a concept. If you gave me a number like 84,200,000,000 and said that's what infinity is, it's not, because I could add 1 and get a bigger number. So because there's no way to equal infinity, I get a round bracket on it. So let me do a few more examples of inequalities, representing them on a number line and representing them using interval notation. Doesn't matter the variable that I use. Like I could do like y is greater than 7. To represent that on a number line, it's going to be similar to the representation that I've just done because it has a greater than symbol, and greater than, if the variable's on the left and you have a greater than symbol, the arrow you're going to draw on the number line goes to the right. So I need to represent every number that's greater than 7 but not equal to 7. Like I need to include 7.001 on my representation because that's a number that's bigger than 7. So I'm drawing a number line, maybe doing more than I need to, but it is what it is. Kind of regretting this choice of 7. The far right edge of my number line goes to positive infinity. The far left edge goes to negative infinity. If I'm asked to represent an inequality that has an or equal to on a number line, then where that number is, I either put a closed circle or a square bracket, meaning that number is included in my answer. If I have an inequality that doesn't have a or equal to it, then when I draw it on my number line, I use either an open circle or equivalently around parentheses. And so this means my solution doesn't include 7, but it includes every number that I draw over that's not 7. And I'm going to draw to the right because numbers bigger than 7 are to the right of 7. So this is the way that my key would show y is greater than 7. Notice no variables come on the number line. The round parentheses would be another way to show this. These are the two different ways I could represent y is greater than 7 on a number line. And now I'm going to represent using interval notation. I want to start with 7 and go to infinity. When I do interval notation, I take the number that's represented, and if there's no bound, if the line goes on forever, I comma the appropriate infinity. Infinities always get round brackets. The number that's mentioned gets a square bracket if there's an or equal to. It gets a round parentheses if there's not an or equal to. There's not an or equal to here, so I'm going to get a round parentheses. Before I jump into the next problem, when I sketch a graph on a number line, I want to have the variable on the left-hand side. It makes it so much easier for me. There's a property of inequalities that says this. Like this is a true statement, that 6 is less than 8. That's a true statement. Anytime I have an inequality, I can invert the inequality if I keep the inequality kind of in the same sense. The pointy end of the inequality is towards the 6. The open end is towards the 8. Saying 6 is less than 8 is a true statement. This statement is considered equivalent. It has the same meaning, that 8 is greater than 6. They're both true. 6 is clearly less than 8. 8 is greater than 6. When I'm asked to represent an inequality on a number line, if the variable's on the left and the number's on the right, greater than, I shade to the right. If it's not set up that way, meaning the variable's on the opposite side, on the right side, I'm going to use this flipping strategy. So if I gave you this inequality saying 2 is greater than or equal to x, here I'm not going to put a solid dot on 2 and shade to the right. If the variable's on the left-hand side, I need to switch this. I need to rewrite this before I graph it using the property that I can switch the direction of the inequality if I switch the sides of the terms. So the problem that I just wrote, 2 is greater than or equal to x, is the same as x is less than or equal to 2. Now I'm going to represent on a number line. And I'm just going to do it one way with the closed circle. And I'm going to draw a really primitive number line. The far left edge of my number line is going to have negative infinity. The far right edge is going to have positive infinity. And boy, I don't need so many numbers. I really just need the number 2 along with the infinities. So I look at my inequality. I see it has an or equal to. I'm going to find the number that's mentioned and I'm going to make a solid circle on it. Now I need to draw a line over the numbers that are less than 2. And to the right of 2, 3 and 4 are bigger than 2. To the left of 2, 1 and 0 are less than 2. I'm going to shade to the left or draw my arrow to the left. Technically it goes to the end of the number line, but I'll stop and put an arrow signifying that it goes on forever. So that's representing both of these inequalities, which are equal to each other on a number line. Now I'm going to represent that inequality using interval notation. And when I create an interval notation, I really need to read from left to right. For greater thans, it's just natural to go from left to right. But this inequality, it goes from negative infinity to 2, and I'm reading left to right. That's just how we naturally read. I would say the inequality version of this would start at negative infinity, the leftmost part where my arrow covers, and it ends at 2. Infinities always get round brackets because you can't equal infinities. The number, if the inequality has an or equal to, it gets a square bracket. If it doesn't have an or equal to, it gets a round bracket. Because this has an or equal to, I'll give it a square bracket. Let's do a couple more. Let's give you y is less than negative 1. And let's do this on a number line. Then in intervals. On a number line, the far left edge of my number line would have negative 1, negative infinity. The far right edge of my number line would have positive infinity. And I don't always even put zeros on my number lines. Sometimes I only put infinities and then the important number. In this case, the important number is negative 1. I know because this problem doesn't have an or equal to, on my number line, I'm going to put an open circle above the negative 1. And now I want to shade over all the numbers that are less than negative 1. If I go to the right, the numbers are bigger than negative 1, so I need to go to the left. That's the number line. And then I'll read from left to right. The is interval is going to go from negative infinity to negative 1. Infinities always get a round bracket because you can't, or round parentheses because you can't equal infinity. The number mentioned gets a round parentheses if that doesn't have an or equal to. It gets a square bracket if there is an or equal to. And here it would get a round parentheses. Those are the straightforward ones. There's a little twist that we need to worry about in a second here that I'm about to do. And that would be an example of these nested inequalities. If I said something like this, 3 is less than x is less than or equal to 7, and I want to represent this on a number line and then with an interval. Let me try to explain this better by looking at the two pieces separately. The two pieces are 3 is less than x and x is less than or equal to 7. This 3 is less than x is confusing to me because it's not in a good order. I'm going to use this flip-flopping and make this x is greater than 3. So what I need to show are the numbers that are greater than 3 but less than or equal to 7. This is a slick way to show, I call it like a compound inequality. This is a slick way to show numbers between in intervals. Here, I'm finding numbers 3 is less than x, which is x is greater than 3, and less than or equal to 7 on a number line that has negative infinity on the left edge, positive infinity on the right edge. I'd put 0 dead center if I left myself room to do it, but I didn't. It is what it is. And on my number line, I just need to represent the numbers that are bigger than 3, not including 3, but less than or equal to 7, including the 7. What I'm going to do is put an open circle on the 3 because I'm not allowed to include the 3 because it doesn't have the or equal to. I'm going to put a closed circle on the 7 because it has the or equal to. And from the 3, I need to go right. I need to be greater than 3. From the 7, I need to go left. So I'm going to go right from the 3, left from the 7. And I'm just going to make these lines meet. These represents the numbers that x is in between 3 and 7, not including the 3, including the 7. The interval notation is pretty easy. I can see the intervals when I have the number line. I'm going to start at 3, end at 7 because that's my interval just stops there. Round bracket on the 3 because of the open circle, closed bracket on the 7. You shouldn't ever see a nested inequality with greater than symbols. It may make sense, but it's awkward and it's never written. Let's do one more of these and then jump into the questions. Like if I did represent 0 is less than x is less than 5. Again, this first 0 is less than x. I can rewrite that as x is greater than 0. And I can leave the x less than 5 alone. So this says x is greater than 0 but not equal to it, and x is less than 5 but not equal to it. So on a number line, my number line starts at negative infinity, it ends at positive infinity. The left-hand portion of this, x is greater than 0, I would get a round bracket, round circle at 0 and go off to the right. The second part of this, the x is less than 5, I'd get a round circle at 5 and go off to the left. I'll just make the lines meet and I'll stop. That represents all the numbers between 0 and 5, not including the 0, not including the 5. And now let's represent using an interval. And I can see the interval. That's the nice thing about graphing on a number line. It kind of gives you the interval. So I'm going to start at 0, end at 5, double round parentheses. Alrighty, now we can get in and do some of the first few problems as I get ready to sneeze here. Sorry. Almost always sneeze twice. I don't know where the second sneeze is at. Alright, so the first two problems, actually the first 4 problems, give me a table, and the table has one of the 3 items, either an inequality, and it wants a graph and an interval, or it gives me the interval we need to create, it gives me a graph we need to make the interval and the inequality, or it gives me an interval and it wants the other 2. What I've been doing is this direction, so let's start with this direction. I want to create x is greater than or equal to 6 on a number line. So I'm going to make my number line that has negative infinity on the far left edge, positive infinity on the far right edge, and I don't feel like drawing 6 numbers, but I will. I guess I would draw 7 numbers. If I just wrote the number 6, it would be okay. I don't need to make my number lines so exhaustively complete. Because this is a greater than, I'm going to shade to the right. And because there's an or equal to on the 6, I'm going to put a solid dot on the 6 and go off to the right. Interval, I read from left to right. I'm going to start at 6, end at infinity. 6 is going to get a square bracket because of the or equal to. Infinities always get round brackets. The second part of this, x is less than 2, let me draw a more primitive number line because you don't have to write so many numbers on your number line to get an accurate graph. Really, if I just put the infinities and then the number that's mentioned in the problem, that's a sufficient number line. And now I'm going to draw x is less than 2. I need to identify 2 on my number line with an open circle because there's not an or equal to. And if the variable is on the left, greater than you shade to the right, less than you shade to the left, so I'm going to shade to the left. That's the graphing part. Now I'll read from left to right and do my interval. My interval starts at negative infinity, it ends at 2. Infinities always get round brackets. The number that's mentioned will get a round parentheses if there's not an or equal to, and this one gets the round parentheses. Problem 2, x is in between negative 4 and 6, and that's what I need to show. I need to represent just a number line that starts at negative 4 for my graphing part and ends at 6 for my graphing part. I really don't even need the infinities. And I'm going to get a round circle on the negative 4 because there's not an or equal to, and by the negative 4, I'm going to get a round circle on the 6 because there's not an or equal to there. So round circle on the numbers that are mentioned, and x is in between negative 4 and 6. It's bigger than negative 4 and it's less than 6. The interval notation, double round parentheses, and I can just copy what I see on my number line. I don't know how well this is showing up. What problem, the next problem has, it has a graph that looks like this. It has a closed circle on the 2 and an arrow that goes to the right. Intervals are very easy for me. I'm going to start at 2. The graph goes to the far right edge of the x-axis, which is positive infinity. There's a closed circle, so the 2 gets a square bracket. The infinity gets a round bracket because you can't equal infinity. And for an inequality, I need an or equal to, and it's right, so it's a greater than. The inequality I'm going to put a greater than because my arrow goes to the right, an or equal to because of the solid dot, and it's bigger than or equal to 2, and then any letter over here is fine. I'll use x. I'm not sure how well this shows up, so I'll darken it and make it better. So the next problem has an open circle above 0, an arrow going to the left. For an inequality, the far left edge of the number line is negative infinity. I'm just going to go from negative infinity to 0. It gives me this number line that starts at negative infinity, ends at 0. So I read from left to right, starting at negative infinity, ending at 0. The infinities always get a round bracket because the 0 had an open. I get a round bracket. For an inequality, my arrow is going to the left, so I know I need a less than. Because it's an open circle, I don't need an or equal to, and the number it starts at is 0, and then I just need some variable off to the left. Next graph, solid circle on 0, going off to the right. For inequality, I'm going to start at 0 because the graph starts at 0. I'm going to end at infinity. Infinities always get round brackets. The 0, because this is a solid circle, gets a square bracket. For the inequality, the arrow goes to the right, so I need a greater than. It has a solid circle, so I need an or equal to. The number it starts at 0 goes to the right, and then any old variable to the left is adequate. This tells me to draw on a number line starting at negative infinity, ending at 2, round bracket on 2. The interval notation, the interval notation will turn into this graph. Tells me where my line starts and where my line stops. My graph is going to start at negative infinity. Never get circles or anything. I just get arrows off to by the infinities. But it's going to start at 2. This says my graph needs to basically start at 2 and go left because the numbers I need to cover are less than 2. So less thans usually have starting with a negative infinity. That's kind of just exactly that there. If I look at that negative infinity to 2, that's exactly, these are the same problems, just kind of snuck that in. And as an inequality, this is a less than because the arrow goes to the left. I sneak my 2 in, and then I have a variable to the left. Next problem, I'm going to make my graph. I'm going to put a negative infinity on my number line, a positive 5 on my number line, a positive infinity. I'm going to identify the 5 with an open circle because it doesn't have a square bracket, so I get an open circle. And I need to cover numbers that are bigger than 5 because it goes to positive infinity. So I'm just making my graph go from 5 to positive infinity. It's a greater than for my inequality. It's greater than 5, and I sneak my x off to the left. This tells me I need to draw a line just between negative 2 and positive 5. I don't really need to write the negative infinity on the far left edge or the positive 5 on the far right edge. I just need to represent the negative 2 and the 5 and draw a line that connects the negative 2 and 5. I'm going to get an open circle on the negative 2 because of the round parentheses, a closed circle on the 5, and connect them. And this has an inequality, starts at negative 2, x is between the negative 2, ends at 5. And when we do these nested inequalities, I can't use greater than symbols. The only symbols I get are less than or equal to. If it's an open circle, it's a less than. If it's a closed circle, it's a less than or equal to. Right, one more of these, and then we'll make a part 2 to this video, possibly a part 3. So, I like number 4. It's a tricky question. I'm supposed to, on a graph, show x is less than infinity. And I wouldn't do this on a test, but it's nice to do for homework. So I'm going to put, for my graph, I'm going to put infinity on my graph. I'm going to start my arrow at infinity. And I'm going to go less, so I'm going to go to the left. So this is a graph of x is less than infinity. I start at infinity. I guess if I wanted to, I could start with an open circle because you can't equal infinity. And there isn't no end. It just goes forever to the left. So this is a graph of x is less than infinity. Start at infinity, go to the left. The interval notation, I read from left to right. My arrow goes all the way from negative infinity to positive infinity. Infinities get double. They always get round brackets. This is an evil trick that I'm trying to make casual about, and I wouldn't do that to you on a test. That's a little bit too, tricky. Next part, x greater than or equal to 7. I'm going to start getting really primitive with my number lines. I'm just going to put the infinities and the numbers that I need. The 7 is going to get marked with a square bracket, or open, closed circle, greater than I shade to the right. The interval notation is going to start at 7, square bracket because of the or equal to, end at infinity. Infinities always get round brackets because you can't equal infinity. Next one, I need to draw a number line, and I really only need to mark the negative 1 and the 4 and draw a line between the negative 1 and the 4. This isn't going to go off to the infinities. X is between negative 1 and 4. I get a solid circle on the -1 because of the or equal to. I end at the 4 with an open circle because it's not an or equal to. And that, you can see the interval. It's going to be square bracket -1, round bracket 4. Next one, it's a less than because the arrow goes to the left. Starts at 1. I get an or equal to because it's a solid bracket, and I need an x. As an interval, it's just going to go from -infinity to 1. The graph starts at -infinity, ends at 1. Infinities always get round brackets, and the 1 got a square bracket. This is tricky. It's double open circle, and I only am allowed to put less thans when I'm doing this nested inequality. So I'm putting x in between the numbers that are mentioned, -1 and 2, and I'm only allowed to use less thans or less than or equal to, otherwise it's going to look weird. And since those are both open circles, I'm going to get double less thans. The inequality, you can just take this straight off. I could just almost paste it in. Round bracket on each of these because they're both open circles. I'm not sure how well this shows up. It has a square, round circle, a closed circle on 0, round circle on 3. To represent this as an interval, I'm going to put my x between the numbers that are mentioned, 0 and 3. I'm only allowed to have less than or equal to signs. The 0, because of the closed circle, gets the less than or equal to. The 3 gets the round because it's just a flat out round circle. And I can see the interval. I can see square bracket from the closed circle on the 0, round parentheses from the open circle on the 3. For the number line, version of this next problem, I need to have a closed circle on 0, and I need to cover the negative numbers because 0 is the end of my graph, and it's going to go off to the left. And this is a less than because I go to the left. It's an or equal to because of the closed bracket. The number that I need is a 0, and I'll throw an x. This is just less than or equal to 0. The next one wants me to draw from -2 to infinity. I'm going to draw a number line that has a -infinity, a -2, and a positive infinity. This is a greater than because it goes off to positive infinity. Less thans go to -infinity, and double less thans go between numbers. On a number line, I need to start at -2, open circle, and go off to infinity. As an inequality, it's a greater than because I went to the right. I don't get an or equal to because I have around parentheses. The number is -2, and I need an x off to the left. The last one, I don't really need the infinities on this because it's not going to stretch to the infinities. I just need a line connecting 1 and 7. And I'm going to get a solid circle on both the 1 and the 7, specifically because they're double square brackets. When I go to write this as my inequality, I'll put the numbers 1 and 7 that are kind of posting up the interval, and put my symbols in. They're only allowed to put either less thans or less than or equal tos, and both of these get an or equal to because they're double square brackets. If you've got this down, then the rest of the section's going to be easy. This is, weird at first, but I don't think it's that bad. So hopefully I've done a good enough job that you can do the problems 1 and 3 maybe before you pop into the second part of this video.